discuss about the Heun's method. So this Heun's method is just like Heun's method and Runge method. Now for Heun's method, that is used for solving differential equations. So first we have to memorize the generic formula, which is y sub of I plus 1 is equivalent to y sub of I plus 1/2 of k of 1 plus 1/2 k of 2 multiplied by the h. H is our step size. Excuse me. I'm sorry for that. So here we have to find our parameters for k1 and k2. So for k1, that would be the function of x of I and y sub of I given an initial condition for our differential equation. We're just going to substitute that value in our equation to get the value of k of 1. Now if we have the value of k of 1, we have to substitute this into finding our k of 2, such that for finding the function of this, that would be x sub of I plus h and y sub of I plus k of 1 multiplied by this step size. So for example, I give an example is given the differential equation 2y dx is equals to 3 e raised to negative x minus 0.4 y, given the initial condition y sub 0 equals 5 and the step size, which is 1.5. Here if we plot it here, that would look like this: x sub 0 equals 0, for y sub 0 equals 5, x is 1.5, incremental, that would be from 0 to 1.5 to 3 and so on and so forth. That would be 1.5. Now what we're trying to find here is the value of y at 1.5. So first of all, for the k1, find the k1, that would be the function of x of I. If I is equivalent to 0, then our x0 would be equal to 0. And then for our y sub 0, that would be 5. Plug this value of x and y into our equation here. That would look like 3e negative 0 minus 0.4 multiplied by 5. This would result into 1, k of 1 is equivalent to 1. For k of 2, that will be the function of x of I, which is 0 plus h, that would be 1.5. And for the y, that would be 5 plus k of 1 times h is 1.5. So that would be 6.5 here. So we're going to plug this into our equation. The 3 in negative 1.5 minus 0.4 multiplied by 6. This is 6.5. So that would result into value of negative 1.9306. Now that we have the values for the k of 1, which is 1, and for k of 2, which is negative 1.906, we're going to plug this into our generic equation here. So that would look like x of I or y sub 0, that would be 5, plus the value of 1/2 of k of 1, which is 1 plus 1/2 k of 2 negative 1.9306 multiplied by our step size, which is 1.5. The resulting would be at y 1.5, that would be equivalent to 5.05 joules. So that is for Heun's method. Thank you for watching.